All right, number 18, solve the inequality. So in order to solve this, we want to do a sign chart because I want to know when it's greater than 0 or when it's positive, okay? So I'm going to make a sign chart, and I have to figure out, since this is a rational function, I have to check two things. I have to check the X intercepts or the roots, so meaning I have to check the numerator. So I have to set the numerator equal to 0. So I subtract 5. So x is equal to -5. And then I also have to check the asymptotes. So I set the denominator equal to 0 as well. So I subtract 2. And since this is an asymptote, remember, it is not part of the domain. Therefore, you want to do this with a dashed line. That way I can tell if it's included or not on the domain. All right. Now, I'm going to choose values in between and plug them in to see if it's positive, negative, or it's not going to be 0. So positive or negative. So I'm going to check -6, -4, and let's check 0. So -6, -4, and 0. So -6, -6 plus 5 is negative. -6 plus 2 is negative. Negative divided by negative is positive. And then for -4, -4 plus 5 is positive. -4 plus 2 is negative. Positive divided by a negative is a negative. And lastly, 0. 0 plus 5 is positive. 0 plus 2 is positive. Positive divided by a positive is positive. So I want to know when it's greater than 0. And since it's not equal to 0, we're not using brackets at all. All we're using is parentheses. So I'm going to go from -infinity to -5. And then union -2 to positive infinity. And that would be my answer for that. That is when it is positive. All right. Number 19. Given x squared plus 5x minus 6, for what values of x is k of x greater than 0? So same thing. We want to figure out when this is greater than 0. So I'm going to make a sign chart because at first I want to see when it's equal to 0. And the way you got to do that is to factor it. So I want to factor x squared plus 5x minus 6. All right. Now, since this doesn't have a coefficient, I don't need the box. I just need to figure out two factors of -6 that add up to 5. So that would be 6 and -1. So this factors out to be x plus 6 and x minus 1 is greater than 0. So here, my solutions would be -6 and +1 for x to be equal to 0. But I want to check when it's greater than 0. So I'm going to make a sign chart. So -6 and 1. And you choose values in between. So here I can choose 0. Let's choose 3 over here. And let's choose -7. -7, 0, and 3. So -7 plus 6 is negative, and then -7 minus 1 is negative, so negative times a negative is a positive. 0 plus 6 is positive, and then 0 minus 1 is negative, so positive times a negative is negative. 3 plus 6 is positive, times 3 minus 1 is positive as well, so positive times a positive is positive. Oh, this is negative. So for it to be greater than 0, it's from negative infinity to -6 union 1 to infinity. And so that would be the answer. All right. Okay, let's go to number 20. So what is the result when that expression is divided by x minus 2? So I'm dividing 4x cubed minus 11x squared plus 12x minus 9. And I'm dividing that by x minus 2. Okay, so you divide your first term by your divisor's first term. So 4x cubed divided by x would be 4x squared. So 4x squared, and 4x squared times x would be 4x cubed, and then 4x squared times negative 2, that would be negative 8x squared. And I'm subtracting all of this. So 4 minus 4 is 0. Negative 11 minus negative 8, so that is negative 11 plus 8. So that would be negative 3. Okay. So this would be negative 3x squared. Then I bring down the 12x. Alright, then I'm dividing this first term by x now. So negative 3x squared divided by x, which would be negative 3x. So negative 3x times x would be negative 3x squared. Negative 3x times negative 2 would be positive 6x, and I'm subtracting all of this. Alright, now negative 3 minus negative 3, so this turns into a positive, so that cancels out. So 12 minus 6 would be 6x. I bring down the negative 9. And then lastly, 6x divided by x would just be 6. So this would be 6. So 6 times x is 6x. 6 times negative 2 is negative 12. I'm subtracting all of this. So 6 minus 6 is 0. Then negative 9 minus negative 12, so that's positive 12. So 12 minus 9 is 3. So I end up with a remainder. So my answer is going to be 4x squared minus 3x plus 6 plus 3 divided by x minus 2. And so this would be your answer for that. Okay. Now lastly, we have, I'm going to go back to number 7. Okay. So number 7, I have a rational function. So it says sketch the graph of f of x and describe the following key features. So X Intercept, Y Intercept, asymptotes, discontinuities, and behaviors. So one of the big things is to remember that X Intercept, you set the numerator equal to 0. Asymptote is the denominator for the vertical, and then the horizontal one, you look at the degree. So first of all, let's factor this out. So x squared minus 25 is a difference of squares, so that's x plus 5 and x minus 5. And then in the denominator, I need 2 factors of 15 that add up to 8. So let's do x plus 5 and x plus 3. All right. So remember, whenever you cancel out 2 factors, that is where the whole is at, right? Removable discontinuity. So at x equals negative 5, I have a removable, blah, blah, blah. So it's at negative 5, and then I have to figure out what the y value is by plugging it into what's left over. So negative 5, I'm over here, negative 5 minus 5 over negative 5 plus 3 That would be negative 10 over negative 2. Negative 10 divided by negative 2 is positive 5. Okay. So, since this is all that's left over, to find the x-intercept, I set the numerator equal to 0. So x minus 5 is equal to 0. So if I add 5 to both sides, it'll be x equals 5. Alright, so my x-intercept is 5, 0. So let's go ahead and mark that. Let's do 5, 0. Okay. Now the y-intercept is when I just plug in 0. So f of 0 would be 0 minus 5 over 0 plus 3, which is negative 5/3. So negative 5/3, it's like negative 1.667. So about negative 1, 2, 3, 4, 5, negative 1. So about right here. Ish. We're just sketching, it doesn't have to be perfect. So my y-intercept is 0, comma, negative 5/3. Now, the asymptotes. So, for the vertical asymptote, you set the denominator equal to 0. So that's here, which is x plus 3. So if I set x plus 3 equal to 0 and solve for x, it's going to be at x equals negative 3. So 2, 3, so about right here. And then horizontal asymptote, now remember, this is where you look at the degree. So there's 3 cases. And I'm going to write them over here. Horizontal asymptotes. So if I have a rational function p over q, p of x over q of x, if the degree of p of x is greater than q of x, then there's no horizontal asymptote. That's whenever you have the slant asymptote and you have to do the long division. Okay. If the degree of p of x is less than the degree of q of x, then it's y equals 0. And then if p of x is equal to q of x, the degree, this is all the degree of, then y is equal to coefficient of p over the coefficient of q. And so here, if you look at this, my degree is x squared and x squared, so they're both the same, and they both have a coefficient of 1, so my horizontal asymptote is 1 over 1, which is equal to 1. So I have a horizontal asymptote at y equals 1, which is like that. Okay? And so I have a removable discontinuity at negative 5, 5. I also have one due to a vertical asymptote at x equals negative 3. Okay, so I have 2 different types of discontinuities. So negative 5, 5 would be over here. Let's do, this is 3, 4, 5. And this is 1, 2, 3, 4, 5. Something like that. Okay. So my graph would look something, let's try that again. Let's make it down here. And then over here at the bottom, it's going to intersect that y-intercept, the x, and it's going to approach -1. Let's try that again. And it's coming down this way. So this is what the graph would look like. And then the end behavior, since I have a horizontal asymptote at 1, then both of the end behaviors are going to 1. All right. So the limit of f of x as x is approaching infinity would equal 1. And the limit as x goes to negative infinity of f of x would also equal 1. All right. And so that's how you would do number 7. Okay, so remember, just vertical asymptote, you set the denominator equal to 0. X intercept, you set the numerator equal to 0. For the y-intercept, you just plug in 0. Horizontal asymptote, you look at your degrees over here. You use this. And then discontinuity, the removable, remember that's the hole, wherever you have a hole in the graph. And that's whenever you cancel out factors. Okay? All right.